We are Florian Eyert, a sociologist, and Paola Lopez, a mathematician, and in this video, we introduce our paper, Rethinking Transparency as a Communicative Constellation. Technological hypes are complex phenomena and deeply connected to societal knowledge practices. In terms of facilitating knowledge about machine learning systems, the literature within FACT has focused on technical methods like explainability and partially on the notions of disclosure and algorithmic literacy. It has not systematically engaged with the conditions necessary for broad discourse and the ways in which existing transparency efforts can be brought into conversation with the general public. In this paper, we address this gap by rethinking transparency as a communicative constellation. Our motivating observation is that value choices are plentiful in the development and deployment of algorithmic systems. A good example of this is prediction. As a technical term, prediction consists in fitting a function to existing data points. The pre in prediction is merely a question of definition and refers to inferring missing data from existing data. Economic, political, and media discourses infuse the pre with non-technical meaning that leads to expectations of clairvoyant capabilities. When deployed to actually make statements about the future, this can have substantial effects for those affected. Taking the future to be like the past can be a source of injustice in its own right. While there are many technical decisions to be made in such predictions, the decision to use machine learning to relate to and thereby shape the future in the first place is a fundamental value choice and thus a political issue. Such issues are determined within temporary social arrangements that emerge from negotiations, frictions, competing claims, power relations, and conflicts. In this paper, we are interested in the implications following from the position that these processes should be shaped democratically. We are inspired by the approaches of deliberative democracy and radical democracy. Deliberative democracy tells us to focus on the sites in which different arguments can be exchanged and translated into political agency while acknowledging ubiquitous power relations. Radical democracy emphasizes the contingency, the possibility of things being different, of all collective arrangements, and the necessity of confrontation. Our perspective thus requires the possibility to bring issues of societal concern to public dialogue, to politicize them and consider them as collectively shapeable rather than purely technical and inevitable facts. Following this approach, the transparency of a machine learning tool is to be measured by the quality of democratic deliberation that legitimizes its use. Taking the ideal of democratic deliberation and contestation as a point of departure, we identify 4 limitations of current approaches to transparency. Firstly, transparency is largely centered around technology. The most important example is XAI, which aims to provide additional technical information about a given model. Other methods, such as model cards and data cards, do focus on social processes, but are still mostly articulated through technical means. This precludes other and potentially more inclusive means of knowing algorithmic systems. Secondly, current approaches to transparency mostly focus on individuals as recipients of explanations or as addressees of disclosure. Matters of collective concern, like the temporalities of prediction, cannot be addressed through these approaches. Thirdly, transparency is commonly approached in a unidirectional manner in which engineers make a given technology transparent to the public. In this process, the concerns of the public do not shape that technology. Fourthly, transparency problematizes machine learning primarily with existing models as a point of departure and attempts to create explanations, interpretations, or disclosures after the fact. All in all, current approaches to transparency do not address the full spectrum of issues involved in democratizing the use of machine learning, not because they fail at the task they're developed for, but because they are developed for different tasks.
We don't argue for replacing the forms of transparency mentioned. Expanding the concept of transparency towards transparency as a communicative constellation, or TAC for short, is, speaking with Patricia Hill-Collins, a way of organizing the thinking tools, those that are already present and those that we add. Transparency as a communicative constellation refers to the society-level quality of the negotiations and debates around the development and application of a given technology. It is a societal achievement that emerges as the result of the communicative effort of multiple actors and includes translations across different fields, disciplines, domains, and spaces. The project of building such a communicative constellation is never finished. Rather, it is an open-ended endeavor. This perspective opens connections to the field of science communication. Through enabling conversations about the facts and values involved in science and technology, science communication can be a vehicle for democratic deliberation, rather than an afterthought in a grant proposal. Viewing transparency as a communicative constellation implies 4 perspective expansions, which open up a larger field of transparency in which specific approaches can be located and analyzed systematically. Firstly, expanding the technical approach to transparency, one can ask about what it means in general for a machine learning system to be known. This opens up the question of epistemology. What is known about what kind of knowledge is produced within a machine learning system? Epistemic transparency means the possibility of abstracting from a specific machine learning system to classes of systems that operate under the same paradigm, and thereby facilitating critique. Secondly, we view transparency not as an individual, but as a collective effort, happening in different fields and contexts, and that is, like democracy, ultimately located on the systemic and structural level. Thirdly, we call for an expansion from unidirectionality to multidirectionality. In multidirectionality, forms of transparency that involve dialogue even before a system is constructed come into view. Both deliberative and radical theories of democracy stress the importance of such dialogue and possible confrontation. Lastly, we propose an expansion from internal to contextual problematization. In internal problematization, it is attempted to render a given model transparent, for instance, by providing reasons for a particular classification. Contextual problematization, in contrast, also takes into account the model's social context and the various external concerns that might be at play. In our paper, we illustrate the approach of tech in a case study about an algorithmic system based in Austria, and we describe implications for a number of societal groups: civil society actors, government agencies, science journalists, NGOs, critical scientists, and others. Thank you for your attention. We invite you to have a look at the full paper and hope that our suggestion will itself prove to be a valuable component of future emerging communicative constellations.